Alright, today we're going to be solving equations, and your focus question is what techniques can I use to solve different types of equations? What techniques can I use to solve different types of equations? And the first type of equation that we're going to talk about is when the variable is being added to or subtracted from. No. That's the first type of problem we're going to look at, is when the variable is being added to or subtracted from. Because depending on what's being done to the variable determines what technique you use or what operation you're going to use to solve for the variable. So when the variable is being added to, let's say we got negative 15 plus x is equal to negative 25. If the variable is being added to, then you need to subtract from each side. Or in this case, do the opposite to each side. If this is a negative 15, you're going to add 15 to each side. And that leaves just the x on one side of the equation by itself. Because negative 15 plus 15 is 0. And on the right-hand side of the equal sign, negative 25 plus 15 is negative 10. And you're done. That's a one-step equation. Again, if the variable h plus 7 pi equals 14 pi, in this case you're going to subtract 7 pi from each side. And that leaves you with just the variable on the left-hand side of the equal sign. So h is going to be equal to 14 pi minus 7 pi is 7 pi. If a minus 5.3 is equal to negative 8.1, can anybody tell me what you would do here to solve for a? Yes, sir. Good. You would add 5.3 to each side. And a is going to be equal to negative 8.1 plus 5.3. Negative 2.8. Let's take a look at a fraction problem. B minus 3/4 equals 2/3. To solve for B here, you're going to have to add 3/4 to each side. The B comes straight down, and it's going to be equal to 2/3 plus 3/4. You need a common denominator here, don't you? What's a common denominator when you're dealing with 3 and a 4, or your least common multiple? 12, very good. So we have to rewrite each fraction with 12 in the denominator. Well, if 3 goes into 12 4 times, 4 times 2 is 8, isn't it? And 4 goes into 12 3 times, and 3 times 3 is 9. So now you have a common denominator, and you can add the numerators. And 8/12 plus 9/12 is 17/12. And you can leave it just like that. Alright, so that's adding and subtracting from the variable. Now let's take a look at multiplying and dividing. If we have negative 1.7 m equals 51. Now the variable is being multiplied, isn't it? So we're going to do the opposite of that to leave the variable alone. So if we take each side and divide it by negative 1.7. What happens to these two 1.7s? They cancel, don't they? And you're just left with the m. And over here we got 51 divided by negative 1.7. Do that in your calculator, please. Very good. Negative. Do it in your calculator. Make sure you get negative 30. If the variable is being divided, again, you do the opposite. The opposite of division is multiplication. So in this case, you can multiply each side by 3 pi. And these two 3 pi's, they cancel each other out. And you're just left with the h. So in this case, h is going to be equal to 9 pi times 3 pi. Nine pi times 3 pi. And really it's 27 pi squared. Because pi times pi would be pi squared. 9 times 3 would be 27. If your variable has a fraction in front of it, If your variable has a fraction in front of it, then you are going to multiply each side by the reciprocal. You're going to multiply this side by 3/4, and you're going to multiply the right side by 3/4. And any time that you multiply a fraction by its reciprocal, you're left with 1. The product is 1. So on the left-hand side, this all cancels out, and you're just left with a j. And then when you multiply fractions, you multiply straight across. So 5 times the 3 is 15. 7 times the 4 is 28. Let's do 2/3 b equals -7. 2/3 b equals -7. Who can tell me what to do first? Yes. If there's a fraction in front of, I wouldn't, you can make it a fraction if you want, put it over 1. Then what would you do? Multiply 3/2 on both sides, the reciprocal. And these will cancel out. And the b is going to be equal to negative 7 times 3 is 21. 1 times 2 is 2. Alright, write this down, please. If the area of a rectangle is 48 and the width is 8, find the length. Alright, so we're going to say that area equals length times width. And if the area equals length times width, and the area is 48, then we're going to get 48 equals, 48 is going to equal the width is 8, isn't it? 8 times the length. So how would you solve for the length? Good. Divide each side by 8. And 6 would equal the length. Any questions there? Write this down, please. If you and two friends pay $60 for tickets, in the ratio of 2 to 3 to 5. If you and two friends pay $60 for tickets in the ratio of 2 to 3 to 5, how much do you each pay? What this means is that 2 times a number plus 3 times a number plus 5 times a number equals 60. So you set up an equation. 2x plus 3x plus 5x, and you make it equal to the total amount that you paid, which was $60. The next step is to combine your like terms. 2x's and 3x's and 5x's gives you 10x equals 60. If you divide each side by 10, your multiplier, or your x, is going to be equal to 6. Now, watch how this works. You take your 6 now and you multiply it by 2. So 6 times 2 equals $12. You take your 6 and you multiply it by 3, and that's $18. And then finally you take your 6, which is your multiplier again, your 6 times 5, and that equals $30. So that is how much each of you paid for the tickets. $12, $18, and $30. Okay? And this is called an extended ratio problem. That's an extended ratio. All right, are there any questions on what we talked about today? Your assignment for today is I've got this 1.1 practice handout, and you're going to do problems 1 through 19. And then tonight you need to make sure that you check Edline for homework.